There he is. Oliver, you okay?
I'm meeting with the teacher.
No, two. It was off. So there's the action, but all the toilets on it. Did we want to?
Oh, number one is not too difficult for you. Number two, probably with that one. But you know, it's so where's that thing that okay. That's that one. It goes up.
Yeah.
Wait, I would just like. I don't know. Oh no, I like maybe try testing. But it's actually good to how this is possible. Well, we're like we're going to be very useful. Oh my God!
This one.
So
Right.
isn't it? It's not. No, it's yeah. No, I took those.
Negative.
Oh, it's 60, right?
Oh.
I don't know that.
Almost. I don't know how. I hear. No, we need it.
That's what
What? Remember when we did like top puddles on it? No, we're starting. Yeah.
all right, here's what I got. Because
Our under. No. Oh, under one.
So I think how long? Listen, you have to put it in like tell me like how long. Waiting, I'm sitting there calculating. Yeah.
Hi, I'm so scared.
10 seconds.
Okay, folks. Are we ready?
I'm so dialed.
Ready or not? Let's go over it. I hope this is not a difficult problem for you. At least not number one. We have zeros at
-4.
-4. Yes, -1 and 3. And then we know the end behavior is so do you start from the left when you do this or from the right? Just don't start from the middle. That's all I'm going to ask today. Either one is fine. If we start from the right, then we just have to make sure it's going up this way. We recognize that at 3 there is a touch. Right? It touches at that 0. It's not going to go through it. And then at the -1, same thing happens. Is that correct?
Yeah.
And then at -4, it's going to go right through it. Is it going to have a twist or anything? And it's going to have a twist on how my stylus is presenting now on this the screen, but it's not a twist. It goes right through it. Easy. Cool. Now, what is the saying? G of x is the reciprocal of f of x. What does that mean? Yes, Max.
You take f of x and then put it as the 1 over f of x.
Exactly. Yeah, so it's going to be this. So I want to know what you know about this function. I'm going to graph it for you guys, but I want to know, Connor, what are some things you know about this function? Where? What kind of asymptotes? The zeros of the previous graph. Oh, that's a nice connection. Okay. So some vertical asymptotes here. Does it have any other asymptotes?
Yeah.
What kind of asymptote and where? How do you know that? Are we good? Very, very nice. Thank you, Connor. Also, when we have multiplicity of twos in the denominator, would you please show me what kind of behavior we're going to see in our graph? It's either going to be this, both going up, or both going down. So how do we decide which one it is?
Plug in like a billion.
You can, or I think we go right to it. I see that from the function, the polynomial function, I'm going to start with between -1 and 3. All those values are positive, aren't they? If we're taking the reciprocal of those positive values, the result will be positive. So it's definitely going to be going up here. Oh, that's poorly done. Up here and up here. Yes? What's that? And we could just fill it in from there. So we have a multiplicity of 2 here. So I'll do this right here. On the other side of -1, it's going to be up on both sides. And then of that -1. So how about at -4? On the right, it's going to be up. How do we know it's going to be up? Yeah, all those values in between -4 and -1 are positive, so the reciprocals will be positive. And the other side will be going down, of course, because of that multiplicity of 1. Now you notice I left off the middle because I want to be very intentional. But please discuss with your neighbor where should the bottom of this part of, or each of these parts of the graph be?
No.
Yeah, that's because there's not.
Okay.
Oh, wait, no.
So where is the bottom of that first branch gonna be? Yes, Jonas.
It'll be close by 0, but it won't touch it at all.
Okay, so it'll be close to y equals 0? Okay. So it's come down pretty low. Okay. What else? Yeah, Connor?
Above the other graph.
Maybe they'll be above the other graph. So like
Here, you mean?
maybe. Okay, anything else?
Just touching it.
It could be just touching the other graph. Yes, Jonas? Say that again.
Maybe it's maximum beach like 5 on the normal graph.
Yeah, we're getting to, yeah, I'm looking for the maximum of the polynomial. Does it make sense that the maximum of the polynomial or the relative max will correlate exactly to the minimum of each one of these branches? It's a reciprocal. Like if this is 5, right? If this value right here is 5, and I don't know what it is. If that's 5, that means its reciprocal will be 1/5. And I hope it makes sense that the highest point on that polynomial, again, should correspond to the lowest point on the graph. Now, did anyone calculate the y-intercept? Of the polynomial is 36. This is 36 right here. So I think that our scale is going to be such that these are pretty large. So, and without calculating exactly, I'm going to say, okay, here's going to be the minimum. I'm going to just approximate down there. This is a little bit more detail than you actually need, but I'm just trying to make some points here, literally. Here, maybe that's the low point. And I think that now gives us a complete graph. Yes, Simran?
Section, that it would touch the maximum of the graph. Why is it going
The first section, when you say first section, you mean
right? That's where you're basically just like the first graph you just.
you do this. So I have 1, 2, 3, 4. Okay, so say that again.
Below the maximum of the black.
Well, if the maximum of the black graph is like 5, And we're graphing the reciprocal. We're talking about the y values of the reciprocal.
So 1/.
1/5. Yeah. Any other questions? I have a question. Oh, yes.
Like the maximum and the minimum are reciprocal to each other and then also the y value or like the one.
All the y values are reciprocals of each other by definition. This is g of x is equal to the reciprocal of f of x. So the x's all stay the same. It's just the outputs become reciprocals. Yes, Jonas.
Where, like.
Wow, are you here from the future? That was my question. That was exactly my next question. We have a few points of intersection. Are they special in any way? Please discuss. Did you figure it out? Show me what's special if you know. Show me what's special if you know. Should be able to show me. Ah, yeah. L, what is it? Does that make sense? That y would have to be 1 for those? If either 1 or -1, because yeah, the reciprocal of 1 is 1. Does that make sense? We don't know enough to say what those x values are. We know that in between like -4 and -1, but the y values of those points of intersection, and that's why I moved it off of here because I accidentally made it on that 36, and 36 can't also be equal to 1. But yeah, the reciprocal of 1 is 1. The reciprocal of -1 is -1. So look, that's a few of you got that. Very nice. Why am I talking about reciprocals?
Because, that you can't see.
Yeah, because we're not done with our graphs, are we? Dun dun dun. You have a blank sheet of paper or someplace you could spread out a little bit? Oh yeah, and we're good with the date. You like that one?
Pretty solid.
It's a solid date, yeah. Yes. Uh,
So when they get stacked, it's when you set the y values of each other.
yeah, here y has to be equal to 1. It's not that you set the y value equal to each other. What's reciprocal of 1? It's 1. Yes.
What about the one that's below that?
Oh, yeah, this y value would have to be -1.
Maybe this is
Yes.
my colleagues. March secant sounds like March 2nd.
What?
Isn't that amazing?
What? That is amazing.
Right here, right here.
That's
okay. Just right there. March 2nd.
What?
Isn't that actually? Oh my gosh. I'm trying to wrap my head around that one.
What? Right, if we write it out. Second. Oh, wow. Look at that.
Dude, you're so smart. This guy.
Oh, that's good.
So it's March 2nd at 5.
Yes.
Wow.
Okay. I like that a lot. Thank you. Okay, we need some, I said we need some paper, so I need some paper too. Go into scratch paper, adding a page. What we're going to do is start with, I'd like a good graph of sine of x from 0 to 2 pi, please. You could do that? I think all but one of you could do that right now.
I know.
You might be the one. I'm sure you could all do it. And I want a really good one. Make your intervals nice, make your plates good. Not too steep, not too shallow, just right. Check with the neighbor after they've done theirs. do that, please discuss what the next thing I'm going to ask you to do is. Not cosine. Not tangent. Cosecant, please. On the same graph, please. And discuss what you're going to do. Like, what are you going to see on the graph of cosecant? You may want to do a different color, or I don't know. What's going to happen to the zeros? What happens to the zeros from sine? They're asymptotes, right? Just like in the world, the zeros become vertical asymptotes. You do the rest. Just in that 0 to 2 pi. Check with the neighbors, see what's going on with them. Okay, so from 0 to pi, can you show me what it's going to look like? From 0 to pi, show me what it's going to look like. Going to look like kind of like a parabola, but it's confined to the vertical asymptote. What do we know about the lowest part of this branch? The lowest. Yeah. So what's it gonna look like? Does that make sense? It's gonna touch it right there. Because the reciprocal of 1 is 1. We're just trying the reciprocal of all these. What do you think? You like it? The next part is really hard though. Impossible. Oh, maybe the same thing. Except it just looks like so. Did y'all bring your pocket cosecant graph today? It's in 2 parts. You need 2 pockets for this. So sine like this, and then cosecant like this. What should we do next? Yeah, let's graph cosine so that we could graph secant. Just from 0 to 2 pi. Same thing. Let's see. Make sure your neighbors are getting the same things you are. You did this already. What's gonna happen from 0 to pi over 2? Show me 0 to pi over 2. Just show me. 0 to pi over 2. It comes up, doesn't it? It has that. Well, we know that the reciprocal of 1 is 1.
Yeah.
And we know it's gonna approach that vertical asymptote. Now, just to make sure we're clear, I don't know exactly what the y value is right there, but maybe 1/10, yes? Does it make sense? The reciprocal of that is way up there. And as I get closer to that pi over 2, when it gets like 1/100th, the reciprocal becomes 100, and it goes up forever. I hope it makes perfect sense. In the next interval, I know that the reciprocal of -1 is -1. That's why they touch. And then from there, all I have to do is go down both directions. And then, of course, finishing this off, we have this coming up this way. Did you bring your pocket secant graph? You need to use a leg. I'm just kidding. There's no problem. It's the same as the other one, isn't it? It's just kind of you see that this.
It's the leave them like this.
Oh, oh. Okay, so you have a little disconnect between your.
Yeah.
Okay.
You see the vision you're left?
Yeah.
Wow.
Wait, like the shadows.
If she's light up love, LEDs on the.
Oh, I've seen that. So we can like.
We could do a group where we do transformation,
What?
but it's straight level.
Oh, I'm loving that idea. What shall we do next? What shall we do next? Okay, tangent, cotangent, good idea. Let's do that one.
I like a miscellaneous question.
Uh-oh. Yes, I'm a little afraid.
What's the penalty like going to the bathroom?
The penalty for going to the bathroom.
Like, I mean,
You missed out on vitamin.
There you go.
that's so good.
There's no penalty. If you need to go, you go.
Oh, really?
Just up to the bathroom.
Oh.
I just ask people to minimize, but if you gotta go,
Oh.
please. From 0 to 200, that's what it is. But I also understand it's part of a larger picture.
Oh, it goes out.
Yeah. Because cosine. Yeah.
That is. Wait. The period is going on.
They're getting cotangent? It's interesting. Does it have vertical asymptotes?
Yes.
Where?
You're right.
0 and pi. Are we good with that?
Imagine. Imagine. What? Now.
Oh.
Wow.
Also, just the zeros from the basic function become vertical asymptotes. What's going to happen with the vertical asymptotes from the tangent? They become intercepts, don't they? I hope that makes sense. Is it true that cotangent of pi over 2 is 0? Cotangent of pi over 2.
Oh, yeah.
Yeah, x over y. 1, yeah. Okay. Do you see what it's going to look like in here? In between 0 and pi over 2, all those values are they're reciprocal. They're all positive, right? So, and they're going to be positive flips, so it's going to look like is that what you're talking about like that?
Yeah.
Yeah. Perfect. Are we good with that? Right, so put all the pieces together. The asymptotes became zeros, zeros became asymptotes. This is all first quadrant, so everything's positive. And points of intersection? 1, yes.
So it's negative. Is 1 comma pi, or is pi over 4 comma 1 still a 1?
You mean on the cotangent?
Yeah.
Good question. Is that still a point on the cotangent? Yeah,
Okay.
perfect. Are we good with these?
No, we're not done yet.
What's the next one we're gonna do? I'll put this in just for fun. No, there's no more trig functions. And just so you know, it's not like you just got 3 more parent functions. Anytime I graph secant, cosecant, or cotangent, I start with sine or cosine. Actually, I do in my mind I do have cotangent. Cotangent actually kind of like more than tangent. And one goes like this, the other goes like this. Shift. It's interesting. Okay, so let's get to the packet. Oh, yes, good. That's the most sensible, yes, 0 to pi. It still goes, yeah. I just limited my range with 10. And I should continue here to be consistent.
Yeah, I don't do a long. So, no.
Okay, so take a look at the 2 graphs. They've expanded further than what we did, but I hope it all makes sense. Take a look at your packet. And just make sure everything's in line. What page is this? 13, thank you. Does it make perfect sense? Like you see the cosine going through that first one, the sine going through the second one, and just building off of that.
Yeah.
Will you please take a moment to discuss the domain and range of these functions? Oh no, the secant and cosecant. Domain, sine and cosine. Too easy.
No, domain.
No questions?
Oh, he was like. 5, 5, 8.
Yeah. Yeah,
They
but
gonna be
still
one
have
of
some-
the- gonna be good. Yeah. Range. If we have, It's like that. It's not
Wait,
more, it's a-
the one for- Yeah, so what?
And domain and negative.
That was coming from. Wait, like, yeah. Oh, but it can't be bought, but it's plus.
Like negative.
Got it down. Yeah. Yeah. So maybe the range is. Oh. Right.
Okay.
So domain. And it's kind of listed here already, isn't it? It talks about vertical asymptotes, but does it make sense? Pi over 2 plus pi k? Wait, why is it pi k? Isn't the period 2 pi? Every pi, exactly. Anytime there was a 0 on the cosine, there is an asymptote. So that is the domain. X not equal to that. Yes.
Right. All real numbers, you said that.
Domain. Good question. X is an element of all real numbers except pi over 2 plus pi k.
Whoa.
Like that. Let me write it so it looks like something. Yes, you can. So what is that? X like something like this? How does that work? I'm not familiar with it. Okay, X not equal to something like that. Yeah, I'm not sure. I'm not sure.
The XBR and the slash, yeah.
Oh, I see.
It's just exclude.
Oh, so just this.
Yeah, they actually have colored.
Yeah, I'm not sure. It's that. So do I have to put the X equals on it? Yeah, after the slat. Equals on? Mhm. Okay, so that says except for. Okay. I'll buy it. If you want to do that, that's fine. And the range from negative infinity to -1 and then 1 to infinity. So there's a gap in the middle of sine secant and cosecant. Yeah, let's do some problems. Any questions about all this stuff? It's the same except for cosecant. Yeah, just pi k. X does not equal pi k for the domain. Okay. Which of the following is a vertical asymptote on the graph of f? I'm going to show you how I want you to do this. Anytime you have an equation with secant or cosecant or cotangent, my recommendation is get rid of the secant. Instead, let's think about this as 3 times what? 1 over cosine of 2x. Or I just write that as 3 over cosine of 2x. And it's asking about vertical asymptote, and we know that there is a vertical asymptote when cosine of 2x equals 0, right? When it's equal to 0. So I don't want you to just guess and check. I don't want you to guess which one. I want you to generate a value that will give you an asymptote. I'll give you a moment to do that.
One over C. Oh, yeah.
Okay. So I'm going to talk you through what I'd like you to do. If we want this to equal to 0, right? If we want cosine of 2x equals 0, what has to be in that argument there of cosine?
Pi over two.
Does that make sense? Pi over 2? Is cosine of pi over 2 is equal to 0? So I'm just going to say that 2x is equal to pi over 2. So that's some analysis there. So we get x equals pi over 4. Now there are other answers. Instead of pi over 2, we could put 3 pi over 2, right? Pi over 2, 3 pi over 2, or 5 pi over 2, something pi over 2. Let me start with the smallest one, and then this happens. Yes.
The, like, your language in your circle, right? It's just an English.
Right, for exactly, we haven't talked about the inverses yet. Yeah, and that's one reason I did this without the inverse. Not today. Example 2, go for it. Well, you could. That would give you another one, but it's just not on here. If Are you ready to be called on?
Yeah.
I'll give you 10 seconds. Okay, ready or not? I want to see what you got. Judy, can you help us out with this one, please? Yeah, okay. Well, we're gonna have a vertical asymptote when what happens in that denominator. Vertical asymptotes. Yeah, exactly. So we're looking for when is sine of pi x equal to 0. So when is pi x equal to 0? Or when is sine equal to 0? Either pi or even before pi 0. So I'm just gonna say, well, I'm gonna set this equal to 0. That doesn't give us one of our solutions, so that's not gonna be helpful here. We'll take that pi over x and set that equal to pi. Does that thought process make sense? Yes. Well, what is sine of pi? 0. Sine of pi is 0. So I want to make this equal to pi. Like that's something that argument setting this equal to pi. So I could solve for x. Sine of pi is equal to 0. Right here is -1, 0. For the zeros, I really like to think of this. I see the 0 pi and 2 pi much clearer on the graph of sine, which is firmly embedded in my brain. And sometimes the x's and y's get confusing on the unit circle. Yeah, so yeah, the sine of if this is a pi, then sine of pi is equal to 0. You just have to make sure that that is equal to pi, that argument. So from here we get x equals 1, which yay is one of our solutions. Yeah. If you're looking for a vertical asymptote, no, you don't always want it 0. Like here, we didn't want it to equal 0 because cosine of 0 actually. What is cosine of 0? 1, and you can think about that in the graph of cosine sense of 1.
That's why we said 2x equal to pi over 2. Because that's when cosecant. Yes. Yes. Perfect. And we look at just the graph of cosine. I didn't draw the figure, but yeah, cosine of pi over 2 is 0. So it's like that argument of pi over 2. Yes. Yeah. Because we're looking for vertical asymptotes.
And since sine of pi x is in the denominator,
Okay.
that's where vertical asymptotes. The concepts are connecting. Yeah, it's a lot. It's a lot to handle. Thank you for pursuing the questioning. Simran, it seemed like you had a follow-up. Are we okay?
Graph that like gives you 0.
Yes.
Okay.
Yeah, that's why I started with 0, but that didn't help with our multiple choice. If this wouldn't have been in it, then I would have gone to pi x equals 2 pi. Yeah, because that's the next place where the cosine sine is equal to 0. Hey, example 3, have you already done it? Oh, this one's talking about range. Interesting. What number is going to have an effect on the range?
3.
The 3. And could you show me what that 3 does to the graph? Stretches it. So whereas there was a gap from -1 to 1, that gap is now from -3 to 3. And that's why our answer is C. Yeah. And example 4, I'll give you a moment. Take one with your neighbor whenever you're ready, or when you're not ready.
Yeah. Yes, that was, I didn't find it.
Do you have a question or answer? If you need to, yeah.
2 pi. Oh, yeah, 2 pi. Pi.
This has, I was like -5, so by the vertical asymptotes, the denominator has to be 0.
Yeah.
So instead of 0 to pi, it's back also, and it's changing I and.
Okay. 8 more seconds.
I and pi.
Okay, I'd like to hear from the one and only Emma for this. How'd you do this, Emma? Okay, do you mind if I just put tangent? Maybe you did that next step, but yes. So k of x equals I.
0 and 2 pi x is going to equal 0.
Okay.
And a potential of pi is equal to.
Say it again, tangent of pi. Do we agree? Tangent of pi equals 0? Oh, sorry, equals 2. And so you said equals pi, right? So x equals 1/2. Are we good? Nicely done. Perfect. Not yet. Not yet. We have some equations to solve. Example 5. Yes, it's a week before break. Not the week before break, though.
Next week.
It's the 12th. Is that next week?
No, the police are the 12. I think like the day before they were.
But testing calendar says no, unfortunately. Oh, and I didn't write it here. Shoot. What's that? It can't be a test on the 19th. Wait, oh wait, when it, oh, there's still a week after that, isn't there? Okay, 19th. I'm sorry. You guys are right. I'll have to get you that information later because there's some confusion apparently. Okay, we got to cosecant of x equals 2. Can we solve that? Exactly. We're not going to solve it in that form. Let's change it into sine. Oh, it could be done anytime. I like to isolate the cosecant first, but yeah, whatever you like. 1 over sine of x equals 2. Okay, solving this. My recommendation is to think about this as a proportion. If you have a over b equals c over d, flip both of them. So we get sine of x equals 1/2. Do you know the solutions for this? I hope you know. X equals pi over 6 and 5 pi over 6. Let's do one more. Example 7. Notice there's a little calculator next to it.
That means the calculator's on.
Does someone need to borrow a calculator? How many have this? Oh, I'm standing correctly. Mine says that. Other than. Sorry, do not try. What's that? The calculator ready. For the final, we're gonna have 2 parts, like one part calculator, one part the algebra. Oh, probably. How much? What that's how it is. Yeah, for this concept. I got plenty. Alright. Why don't you keep the case with you just in case? Thank you. Sure. Oh, yeah, I got it. What's your? Just put that's the right one over 10.
Oh, you're exactly.
I mean.
Oh,
Yes.
Oh, why did you? Here.
Get my 4.7.
Wait, no, no. Wait, you just said, right next to us. Oh. You're too slow.
Okay, folks. Did you do this?
There's no code. Yeah.
Is this what you did? I'm not a calculator, so I got this. Okay.
Yeah.
Okay, so after graphing, how's this gonna help?
You make it easy.
So there's y equals 2. Now we just have to find point of intersection. Should I use the trace button to do that? No. No, stay away from that trace button. We're gonna use second trace. And now intersect. So first we're gonna load off of it. So enter, guess anywhere near it's fine. Is that what you got?
That's my
Yes.
but yeah, that's what I got.
Hey, can we just use?
For some of you can. Is the y value a surprise?
No.
Okay, good. Any questions about this? Did anyone do it differently on the calculator? Oh, zoom for this. I forgot to share that. Okay, so, but I do want to talk about one other way to do this. I want to take it as far as we can by hand, of course. So 3 minus 1/2 secant x equals 4, and I think I'll go directly to secant x equals -2. Is that right? Oh wait, I'm on the wrong problem. Excuse me. No wonder it was so unfamiliar. Sorry about that. Yeah. Okay, we'll take this and set this equal to 2. Can I do this? Cotangent. Actually, I'll do this. Tangent of 0.5x minus 1 equals well, is equals 2, and then move that 3 equals -1. Is that right? And then I'll cancel those negatives. Yes. It was a 3 minus equals 2, so I just did a little work in my head. So I subtracted 3 and then multiply both sides by -1. Got this. And now if I cross multiply, I get tangent of 0.5x minus 1 equals 1.7. So you could, again, use your graphic calculator to do this. It's a little bit simpler to plug in. But let's say you didn't have a graphic calculator. Let's just say you had like one of those the middle school calculators, like purely scientific. What could you do next? Discuss with your neighbor. What could you do next if you didn't have that graphing feature? Here's why.
Oh, yeah. Oh, you could. Oh, but it's been.
So you've built the substantial tangent.
Then you find that and set that equal to 0.5x.
Okay, so. Would it make sense next to just divide by tangent? Are we okay with that?
No.
Good, that's definitely not okay. So how do I proceed? No. Nice. And I'm just gonna leave it as this tan inverse of 1.7. Right, to cancel that tangent, we need to take inverse tangent of both sides. And now it's easy to solve for x, isn't it? Just add the 1. 0.5x equals 10. I'll put the 1 in front so it doesn't get confused with the argument. 1 plus tan inverse of 1.7. And how should I isolate x? Either divide by 0.5 or multiply by 2. Wouldn't that do it? Multiply by 2. 2 plus 2 tangent inverse tangent of 1.7. That'll get you the same answer we just got on our calculators from graphing. I want to make sure you're not dependent on that graph. You can do it other ways. Does that make sense? You may want to type that in just to get that satisfaction and say, oh, it's the same 4 point whatever. I hope it's the same. You have some time for the homework. Just a little bit long tonight. It's on the Pearson. It's a little bit on the long side. Is it the same thing? Yeah. There is. It's just, you have to go into it. I think, is it under math? Yeah. My pleasure.
You type a guy. Yeah. You type a guy saying you're set. Wait, it's not that. It's not along with that.
Thank you for your help with the chess. Are you playing?
No, I'm just setting it. I don't know. But they could just play.
Oh, nice.